Good morning, students. Welcome to week 5 of MOOC course, Introduction to Proteogenomics. I hope all of you had a good weekend and good time of celebrating some festivals this week, from Muharram to Raksha Bandhan. But still you managed to accomplish your assignment and you are keeping up the pace of the lectures for this week. So this week we have some very exciting lectures lined up for you, especially which are going to be useful in this day and age when you are thinking so much about machine learning and AI. How to utilize those skill set for looking at the big data from proteomics and genomics. Just to refresh you, every week we are providing you some reference materials which are uploaded in the video description. Please do read additional material for your knowledge. We are also giving you an opportunity to interact with us live and clarify your questions and doubt every Saturday. So all the students who are writing their queries and want to take a slot, please do so by Friday evening. And Saturday morning, we do that interactive session. And of course, you are keeping pace of the assignments. So coming to this week activities, I think the first we will, on the lecture 21, we will talk few things which will be covered by Dr. D.R. Mani from Broad Institute of MIT and Harvard. He's quite experienced, very renowned in various CP-TAC projects. And he's going to talk to you about some of the machine learning algorithms and its applications. There are different basic concepts required to understand these complex workflows, especially you need to know supervised and unsupervised machine learning, different type of clustering approaches like hierarchical clustering, k-mean clustering, fuzzy clustering, consensus clustering, etc. He's also going to give you an idea for not only clustering, but also how to visualize the clusters and also look at the principal component analysis. I think as you're going along, I'd also recommend you to explore a software known as Orange, which is open access software, which can be utilized with very minimal programming knowledge. Also, you can use that software to play with your data and try to see if you could analyze your workflow using this open access software. But of course, the basic concepts are going to be very crucial for you, and also you can utilize different programming ways to accomplish these objectives. In the next lecture, Dr. Bani will talk to you about different type of hypothesis testing and what is assumption about the population parameters. Null hypothesis, alternative hypothesis. I'm sure you have been studying those, but now let's read those more in light of the big data analysis. Concepts will remain, basic concepts will remain the same and crucial to think about the type 2 errors, what are the false negatives, what is the rejection of null hypothesis, how to use the hypothesis testing for true and false positives. All of these will be very interesting and very crucial concepts which Dr. Mani has described in a very simplified and lucid manner. Next lecture will talk to you about a software which has been developed by the Broad Institute team known as Protege, which is open access software. It's quite useful to learn about this software. There are different type of software and workflow available in proteomics, and we keep recommending you to learn some of these so that you are aware for various activities yourself. You can look into the MetaBonaList, you can look into the Protege, you can look at Perseus and see which one you like the most. If you're a little bit more into programming and our language, you should be quickly pick up some of these things. But even otherwise, these are very user-friendly software. Without programming knowledge also, you can make use of them. So Dr. Mani is going to show you how to first install the Protege and load your data set, what are different parameters involved here. And then of course, he will show you some analysis and exploring results for that. Next lecture will continue from the this lecture about Protege and especially how to take your data to do the log 2 transformation, normalization, the data filtering becomes very important. All of these things, what is going to give you an idea that proteogenomics generates so much data, but at the same time, the big data also has many of the constraints about looking at so much noise could be there. Data comes from different centers, different places, different individuals, how to normalize all that, how to filter the data. And then finally, only you can move on to the statistical approach to look at the principal component analysis, scatter plots, volcano plots to find out what is the most significant differences in your control versus disease group. All right, so in the last lecture, lecture 25 of this week, uh, you'll start seeing how to utilize some of these knowledge for doing integrative proteogenomics approach to understand about human proteoforms and their role in the living system. This will be covered by one of the scientists from IGIB, Dr. Debashish Das, and he's going to give you some reference and some application context from Dr. Rudy Ebersold's lab, some of those published work. And he's also going to talk about the different concepts which you have covered in the previous lectures, how to utilize those knowledge and especially also look into the fast discovery rate for the data analysis. I hope this week is going to enlighten you some of the very crucial basic concepts which is important. You many times use online software or commercial softwares, and based on those you can get some output, but you have no idea about the fundamentals and the basic concepts involved. So this week is going to make you really more confident that you understand now what is actually going to be done with these softwares and what can be output from that. All right. So enjoy watching these lectures and finish your assignments. We'll be happy to take any questions and your comments at the end of the week. Good luck.